So in this case, we are going to consider another typical exam revision as we are preparing for our Term 3 examinations. So that was from the province of Gauteng, and that was our mock test for Term 3, a revision test, which we are going to consider. As we can see, out of 50 marks, let us see how these typical questions are given as we can consider our Term 3 topics. So there we had Section A and Section B, okay, based on the prescribed content framework in the CAPS document, meaning to say based on our annual teaching plan. Remember, I gave you your topics for your Term 3, which is in this case considering the multiple choice is going to be any of these topics that we are given, the 4 questions based on covered topics: algebraic expressions, we're going to have algebraic equations, the geometry of straight lines, and also the geometry of 2D shapes. So I have introduced each and every topic, so make sure that you go through, understand the topics before you attempt question papers. As an individual, learn the basics, know the basics, all right? Understand each and every basic of the topic that you are given. So anyways, without wasting our time, make sure that you read each and every instruction that you are given. On question 1, for each questions, choose the correct letter of the correct answer. All right, so there are letters that you're given, which is A to D, that you're supposed to choose from. So 1.1, simplify this expression. So we go to 1x squared plus this, 2x squared plus 3x squared. Remember, these are like terms. We've got x raised to the same exponent, same power of 2. So when we are adding, we are simply going to combine the coefficients of our variables, which is 1 plus 2, which is 3 plus 3. That is going to be 6. All right, so you add. They are like terms, so you simply add. So that's 1 plus 2, which is 3, plus 3, which is what? 6. So the answer was going to be 6. With the x squared as it is, it's going to remain as it is. That's how we're going to combine our like terms. So the best answer there was going to be what? B, where we've got 6x squared. All right, let's see on 1.2. The equation of y is equal to 2x minus 1 is given. Which table representing the equation? Which of the table is representing this? All right, so we've got table A up to D. So it's simply substitute, guys, as we are given the input, our x. These our x values. Substitute these values and see if they correspond to the y values. When x is minus 1, you substitute in place of x. So y is equal to 2 into our x, where it is negative 1. All right, so that's it. Then we're going to subtract this one. So you can even use a calculator, guys. This one is straightforward. 2 into negative 1. Then we're going to subtract 1, that is a negative 3. All right, so where we have got a negative 3, there is a negative 3. This one is totally wrong. There is a negative 3 here. There's a negative 3 here. All right, so this one is also totally wrong. Okay, let's move on. When x is 2, all right, so when x is 0 there, the next is what is 0. You substitute in place of x. We're going to put a 0 here. All right, so that's 2 times 0, which is 0 minus 1. So our answer was supposed to be negative 1. So there, all right, this one is totally, guys, once the first one is wrong, it means the table A is not part of our answers. Table D is not part of our answers. So now let's compare table B and C. So where x is 0, you can see that the y value will be what? Negative 1. There is a positive 1. Here there is a negative 1. So meaning to say table B is totally wrong because of this part which is wrong. It makes the whole table to be what? To be incorrect. So the correct one was going to be C. But anyways, let us finish and see if x is 1. Are we going to get the same answer, which is 1, when x is 1 here? 2 times 1 is 2, then minus 1, that's a 1. As we can see, that's a 1. All right, let's move on to the other one. When x is what? When x is 4. All right, we substitute 4. 2 times 4, that's 8. Minus 1, which is what? 7. As we can see, that's exactly all these values, they correspond. So the best answer was going to be C. All right, so that's our question 1.2. From that equation, substitute. You're already having the answers, guys. So substitute into the equation, test your values. All right, which one satisfies the condition? 1.3, what is the size of M? All right, we have got vertically opposite angles, which we do understand that vertically opposite angles are equal. All right, they are equal, vertically opposite. So M plus 20 and 100, they are equal, vertically opposite angles. So M plus 20 degrees is equal to 100 degrees. These are vertically opposite angles. All right, remember your condition. So let us solve for M. Take this to the other side. That's going to be a negative. So M is 100 minus, the moment it jumps the equal sign, remember, it changes the sign. So M is going to be 80 degrees. All right, 100 minus 20, which is 80 degrees. The best answer was A. All right, let's see. 1.4. Which one of the following triangles is an equilateral triangle? An equilateral triangle, the one that we do understand that all sides are equal and also all angles, they are equal, each being what? Being 60 degrees. Remember your properties of an equilateral triangle, as I mentioned before. So A is totally wrong. These angles, we do not have 60, 60. So A is totally wrong. All right. B, there is an angle of 60 degrees, 60 degrees. Remember, angles in a triangle, guys, they add up to 180. So if you subtract these two angles that we are given, the 60 degrees and the 60 degrees, this was going to give us 60, right? 120 here, 60 plus 60 is going to be 120. Then 180 minus 120, which is what? 60 degrees. As we can see, the remaining angle is what? 60 degrees. That's our remaining angle there. 60 degrees. So it maintains this, it keeps this part. We are back to this. All of these interior, each is what? 60. So meaning to say B is actually an equilateral triangle, as we can see that each angle is what? 60 degrees. Thus we have got each angle equal. That is 3 angles. All the 3 angles are equal. All right. On C, all right, so this diagram is corresponding to C. Then D is going to be the other one that is on the next page. All right, so this one is totally wrong. That's an isosceles. 2 sides that are equal. So that's an isosceles. All right, on D, this was our D. It's a right angle triangle. There's a 60 degrees. This is going to be 30. These angles are not 60, 60. So it's not an equilateral triangle. So the best answer for an equilateral triangle was going to be on B, where we have got all angles are equal, 60, 60, 60. Okay, let's see on question 1.5. They said the triangle ACB is congruent to, so that's a congruent that we have, congruent to triangle ECD because of what? Here, these are the triangles that we are given. So why are these two triangles congruent? Triangle ACB, why is it congruent to triangle ECD? All right. If you are to check AC, the side of triangle ACB, this one, and this triangle here. If we check properly, A to C, it is a side, this one, AC, which is exactly equal to CD of this other triangle. All right, we have got A to C. And there we have got a side which is CE, exactly the same. And we also have the corresponding side in this case here. I mean the angle at C and this angle at C. They're exactly the same of both triangles. And the side, this one CD, of this triangle CB, all right, if you consider that triangle here, CB, length of C to B, it is the same as this one, C to D. It is the same. So we have got the side to the angle to the side. So that's side, angle, side. Side to the angle to the side. Side, angle, side. Side, angle, side. That's C was going to be the best answer where we have got that condition from one part to another as we are given the two triangles. All right, so that was it here. And question number 2, without wasting our time, solving simplification of, on our algebraic expressions. So they asked us to simplify this expression, simply collect the like terms in that case, all right? So 2.1, we had 2x and 2x, and this minus 3x. Those are like terms, 2x and the minus 3x. So collect those, that is, we're going to have 2 minus 3, which is 2 minus 3 is what? Negative 1. So it was supposed to be negative 1x, of which negative 1x is same as what? Negative x. Then we have the numbers 4 and minus 2. So 4 minus 2 is what? That's 2. All right, that's a positive 2. Can even use your calculator if you do not understand your directed numbers. All right, so that is minus x plus 2 as our final answer. All right, then 2.2. Again, simplify these two. That's a product there, 2x to the exponent of 4, y times 3x to the exponent of 2y, everything over 12x to the exponent of 6, y to the exponent of 2. All right, so what can we do? As we can see in the numerator, we have a multiplication, a product. There is a product there. It's not addition, it's a product. So the best way, let us just multiply the numbers together. 2 and what? And 3. That's going to be 6. Then the terms x4 and x squared. Remember the product, x to the exponent of 4 times x to the exponent of 2. Same basis, you're multiplying, you add the exponents, remember? So you're going to add your exponents, the 4 and the 2. So these are our exponents. So thus, it's going to be x to the exponent of 4 plus 2, which is what? Which is 6. All right. Moving on to the y, there is y and y there. So you're going to multiply y times y. Same basis again. So add the exponents. This is 1, this is 1. So if we add 1 plus 1, that was going to be 2. So that's y squared. All right. Everything over the denominator as it is 12x to the exponent of 6, y to the exponent of 2. Okay, so that is what we have now. That is what we have. Let us see what we can do. As we can see from the numerator and denominator, this part is exactly the same. So just cancel, guys. This one and this one can cancel. This one and this one can cancel. All right, therefore, let us reduce 6 into 6, that's 1, into 12, that's a 2. So that was going to give us what? 1 over 2 at the end. All right, so just like that, the x and the y have cancelled. Remember, they're exactly the same, so those, they can cancel each other. So that is our 2.2, 1 over 2, just like that. Okay, then considering question 2.3, We are asked again to simplify, all right? And let us see what we have there. Simplify 2.3, negative 12x, negative 6, everything over 6, all right? So remember those algebraic expressions where we have got addition, subtraction in the numerator, and I said you can simply take this one to 6, then this one to 6. You can divide each and every term minus 12x to the denominator. So that's minus 12x over what? Over 6. The minus 6 to the denominator also. Addition and subtraction can be separated with each term on the denominator. All right. Anyways, let us simplify and see what were we going to have at the end. All right. So that is divide minus 12 divided by 6. That's a negative 2. And with that x, so it's going to be negative 2x. 6 and 6 was going to cancel. We get a 1. So that's negative 1. Okay, just like that, we are done. There's nothing that we can do. We cannot simplify any further. All right, then 2.4 for 2 marks. Simplify again. All right, so there is addition, there are brackets, this and that. All right, so let's see. 2.4, there is 2p, then plus 2p times the bracket of 3q minus 5q, all right? Plus there is 4q times the bracket of minus 3p, okay? So remember your board mass. All right, our board mass. Okay, let's see. What are we gonna have here? So working with the brackets, yes, there are brackets here. There is a bracket. Okay, there's a bracket. So let's see what we've got inside the brackets and can simplify that part. So meaning to say that 2p is just going to remain as it is because it is being added. All right, so just ignore that one. So 2p plus, all right, so that's 2p plus. This 2p is supposed to multiply this bracket. So let's simplify what is inside of the bracket. So it's going to be 2p times, what are we going to have inside the bracket? So let's subtract 3 minus 5. That's a negative 2. So that's negative 2q. Okay? Plus 4q, which is going to multiply this. So this condition, I'm not going to simplify it, this one, because as you can see, it is the same as this one. The presentation, it is the same. So I want us to do that one at the same time, all right? So this is 4q. I'm just going to rewrite as it is times minus 3p as it is given. So I want us to see that this is exactly the same presentation of these two. Here, 2p times this. Here there is 4q times this. Same presentation. So let's multiply and see. The 2p is on its own, this one. Is on its own. Remember, there's a plus. So we're working on board mass here. We need to expand these brackets. What is expanding? It is the 2p. So we're going to have 2p. We expand now this one times this one. Here, the product of these two. So that's positive to a negative, which is negative 4pq, right? P and Q. All right, we do the same thing on these two. They have the same concept. From 4q up to this, the product. So you multiply positive to a negative. That's a negative 4 times 3, which is 12. Q and P is going to be QP. But QP is same as what? PQ. This is one and the same thing. So instead, we can write it as PQ. Since this one, we have written it as what? As PQ. All right. So this is exactly one and the same. So it is best for you to write in the same way so that you can see that these are like terms at the end. We do not have brackets. So we're back to addition and subtraction. These two can be taken at the same time. that is, we're going to collect our like terms. That's the part of addition and subtraction. There is a PQ. There is also a PQ here. So these are like terms. These are like terms. So that is going to be 2p minus 4 minus 12, which is what? Minus 16 pq. Remember, your like terms, you just combine the coefficients. So minus 4 minus 12 is what? Minus 16. Just like that. So we are done. We cannot simplify further. These are not like terms. We do not have q here. So we're just going to leave it as it is. We are done. So that is how these questions are given as. Just have to be careful on your simplification. Otherwise, if you do understand your algebraic expressions, it's not going to be that difficult. Just follow up the stages. On 2.5, we are given that x is 2 and y is negative 5. So determine the value of this expression for x squared y plus y to the exponent of 3. So just substitute, guys. 4 into our x. Our x is what? Is 2, which is being raised to the exponent of 2. All right, then we have got y there. We are multiplying to y, which is negative 5. Just like that. Plus y to the exponent of 3. The value of y as it is negative 5. Everything must be raised to the exponent of what? Of 3. So this is what we're going to have. You can even use your calculator. 2 to the exponent of 2, that's 2 times 2, which is what? 4. So we're going to have 4 times 4 times negative 5. 4 times 4, 16 times negative 5, which is negative 80. All right, so it's going to be negative 80 plus negative 5 to the exponent of 3. That is negative 125. Negative 5 times negative 5 times another negative 5. So this one is positive 25 times a negative 5, which is what? Negative 125. Remember where a positive and a negative is, we are going to have a negative at the end. So that's negative 80, negative 125. Minus 80 minus 125, which is what? Minus 205. You can even use your calculator to verify this. Minus 80 minus 125. All right, or you can even use your calculator on the first stage here to verify that it was 4 open bracket 2 to the exponent of 2 open bracket minus 5. This one minus 5. You close the bracket. Then there is plus open bracket minus 5 and negative here inside the bracket. Right, so that's negative 5 to the exponent of what? Of 3. So as we can see, we've got the same answer, which is what? Which is 205. So that is how these questions can be given as. So that's negative 205. On question number 3, it is now on solving of equations. Back to our equations. 3.1. Solve the following equations. So that is 3.1. We've got negative 3 minus open bracket x plus 2 is equal to x plus 8. So remember, as you had your simplification also, when there are brackets on equations, you must simplify those brackets before solving. All right, so let us get rid of the brackets. The number affecting this bracket is a negative what? A negative 1. If the number is not there, it's there. There's a negative 1 there. All right, so meaning to say you're going to expand the brackets by negative 1. You distribute negative 1 times x, which is negative x. Negative 1 and a positive 2. So negative, positive is negative. That's equal to the right-hand side, x plus 8. All right. On the left-hand side, we've got like terms, the minus 3 and the minus 2. So collect your like terms. Minus 3 minus 2, that is minus 5. So we've got minus 5 minus x equal to what? X plus 8. So there we're going to collect the like terms. That is, take the x to the other x there. So the moment it jumps or crosses the equal sign, it must change the sign. So that is minus x. This one, the moment it jumps there, it will change to a minus. So it's now minus x is equal to, on the right hand side already we've got what? A positive 8. So taking the minus 5 there, it's going to be positive. The moment it crosses the equal sign, it changes this sign to a positive. So that's a positive 5 that you're going to have. Minus x is simply minus 1, minus 1. These are like terms. So minus 1 minus 2x is equal to 8 plus 5, which is going to give us 13. All right, so that is it. Let us solve for x. Divide by negative 2. We have got a product here, so we're just going to divide by what? Negative 2, both sides, to get rid of that x. So 13 and negative 2 is going to be negative 6,5. We can just use our calculator here. 13 over negative 2. All right, so that's minus 13 over 2. Change this on SD. That is to decimal, negative 6,5. All right, just like that. Just like that. All right, so that was our question 3.1 for 3 marks. And let's see. Another question 3.2, we are given again to solve for x. We have a fraction in that case. All right, so 3.2, there is 4 plus x minus 2, everything over 4. This is equal to minus 2. Yes, we have got a fraction, but it's not a single fraction because of this number 4. So let's get rid of that 4. We can take it to the other side of the equation so that we remain with a single fraction, x minus 2, everything over 4. This is equal to what? The 4 to the other side is going to be a negative. So it was going to be negative 2, negative 4, which is negative 6. Negative 6, it's a whole number, this one. We do understand that. But it can be, it's an integer that we have just like a whole number. So we can rewrite this one as a fraction. The moment we just write it as over 1, it's now a fraction. So a single fraction to another single fraction, it is possible now for us to cross multiply. We have a single fraction, that's a single fraction again. So cross multiply, 1 is going to multiply x minus 2. So that's x minus 2 is equal to 4 multiplies on the other side minus 6. 4 times negative 6, that's negative 24. All right, so it's going to give us negative 24. Then the minus 2 on the left hand side, we can take it to the other side or simply add 2 so that this can cancel. So x is equal to minus 24 plus 2, which is minus 22. All right, can use your calculator again. That one, minus 24 plus a 2 like this, that's negative 22. Okay, just like that, just like that. So guys, do revise as many questions as you can as you are preparing for the exams that are ahead of time. Do as many question papers. Just try to figure out how do they ask and test yourself with a lot of question papers. All right, so on question 3.3, we are asked again to solve for x on an exponential equation. Remember, if the bases are the same, automatically we can equate the exponents to say a is equal to b because of same bases. So can we write these two numbers in the same base, 3 and 81? Yes, it is possible. 3 is already in simplest form, it's a prime number. So let's rewrite 81 as a base of 3. So remember, that is 3 times, you test until you get 81. So that is 3 times 3, 9, 9 times 3, 27, 27 times 3, 81. So 3 multiplies itself 4 times, which means that's 3 to the exponent of what? 4. 1, 2, 3, 4. So 3 to the exponent of x minus 1 is equal to 3 to the exponent of 4. When the bases are the same, as we can see, automatically these exponents will be equal. So therefore, x minus 1 is equal to 4. We have a linear equation, just like all these other equations that we had of linear. We can solve for x. What is affecting x? The minus 1. How do we get rid of that? Add both sides or just take it to the other side. So this was going to cancel. So x is equal to 4 plus 1, which is what? Which is 5. So many ways of attempting your questions later on in terms of how to solve these equations. You're going to solve in any way that you do understand. All right. On question number 4, we are given 4.1. Are the following statements true or false? Give a reason for your answer. 4.11. When two lines intersect and extend vertically opposite angles are equal. All right, this is true, guys. This is a property that we do understand from our lines. Vertical opposite angles are formed when two straight lines intersect and extend. 4.12, we have got, all right, x plus y is 180 degrees. All right, angle x and angle y should give us 180. All right, we are not told anything about these two lines to say they are parallel. We are not told about that. So if we are not told, and also we are not told that this is 90 or what, we cannot see the indication of a 90 degrees. So we do not assume to say these two lines, they are parallel. I told you guys, when they are parallel, they must indicate like that, or they must give us to say this line AB is parallel to FE. When they have got that statement, therefore we can use that statement because they will be what? Co-interior angles. If these lines were parallel. If. But there's nothing to show us that these two lines are parallel. We don't assume by the way that these lines are drawn. No. We don't assume. So we cannot say this statement is correct. So that's false. Because B is not parallel to, right? So is not parallel to FE. We are not, there's no statement to show that they are parallel. We are not told about that. And there is no indication for that. All right. So that is what we have. If we are given this indication, 4.13, this indication here, they are trying to tell you that angle B and angle C are exactly the same. The indication they are giving you there. These two are equal. So if angle B is equal to angle C, is this statement true that AB is parallel to CD? AB is parallel to CD. Yes, because they will be what? Alternate angles. So look, guys, the angles, these one, they are equal. So automatically it gives or it tells us these two lines are parallel. So it's true that these two, they are what? Parallel, since angle B is equal to angle C, which makes them to be what? Alternate angles. The difference that we have on this question, I want you to understand this question. The difference is that they gave you a statement. They want you to prove, they want you to say, is this true? To say if I add x and y, I'm supposed to get 180. The reason why I'm saying this one is false, it is because we are not told that these two lines are parallel. If they gave us to say x plus y is equal to 180, then they ask you to say, are the lines AB and FE parallel? If it was like that, you were going to say they are parallel. If they told you that this, then they want you, like what is happening on this question. They gave you these two angles that are equal. Then they're asking you to say, are these lines, like on the condition, these two lines, they are exactly parallel. Is that true? Yes, it is because of what? Alternate angles concept, where we form a Z. When these angles are equal, it tells us that the lines automatically are parallel. That was a difference from the previous question. For this type of a question, they must indicate that they are parallel, or they must tell you that these two lines are parallel for you now to conclude a certain statement. But if you're not given that, it means it's false. You cannot assume that the lines are parallel from the way they are drawn. Here, it is not assumption of the lines the way they are drawn. It is from the equal angles B and C. That indication is showing that these angles are equal. All right. So they will be playing around with you guys. They know that some of the questions you just see, okay, this one you think is parallel. No, you're not supposed to assume. You're supposed to be told or to see these ones. You know that they are parallel. Okay. Anyways, given that AC is parallel to DE, meaning to say to DF as well. And also angle ABD, AB to D, the angle that is formed here is equal to DBE, DBE, all right? These two angles, they are equal. These two angles, they are equal. From that statement alone, the question is on 4.21, calculate the value of x. Provide reasons, all right, for 4 marks, the value of x. So what can we say about our x? 4.21. What can we say about the angle x? Or how can we end up having this angle x? If we check properly, they gave us this condition that these two angles, they are equal, which is not a problem. The x at B and the x at E must be equal, alternate angles, because we have got these lines that are parallel. So where we form a Z, alternate angles. So automatically we are saying angle BED, angle BED is equal to x, alternate angles, all right? So that's x here from our alternate angles. Since these two lines are parallel, AC is parallel to what? To DE as given there. So that's angle x. All right. Another thing that we can use is this condition of the angles that are equal. Angle ABD, all right, and angle DBE. They told us that they are equal. So let us find one, which is angle B inside of the triangle, angle DBE, which is inside of the triangle in terms of x. Angle D to B to E, all right, DBE, this one, will be equal to 180 degrees minus these two angles that are inside the triangle, the 63 and the x. So we have got 63 plus x. So let's subtract from 180 minus expand, minus times 63, minus 63, minus times positive x, minus x. Collect your like terms, 180 minus 63. That was going to give us 117 degrees minus x. So this is our angle DBE, 117 degrees minus x, which is the same as this one, 117 degrees minus x, because we're told that these two, they are equal. So here we're talking about angles in a triangle. All right? So if the angle DBE is 117 degrees minus x, this one, and it is exactly the same as this angle B, therefore we can calculate our angle x. There is a statement that we can use. You form an equation from something that is already given. You do not form an equation from what you filled in, like you filled in your triangle. It is the one that you had to fill this angle. You also fill this one. You cannot use that statement to say angles in a triangle add up to 180 for you to solve for x. It will neutralize. It will cancel. The x will cancel. You can't find x from there. So what you do, you use information from one, then you use it to solve, to form an equation and solve. The information now can be angles on a straight line. Yes, it is us who calculated this, but it was not from the triangle. It is something that is on its own now. So let's work with that statement and solve for x. Because we are now having angles on a straight line. So this was going to give us the value of x now. So now we can say 117 degrees minus x. If we add this one to another 117 degrees minus x, and this x that is remaining there, we must obtain 180 degrees, which is from what? Angles on a straight line. So that was the concept there. Angles on a straight line. So let us collect our like terms and solve for x. 117 added to 117, that was going to give us 234. So 234 degrees minus x. All right, there's a minus x here and a plus x. This one, they cancel. So you remain with this one, minus x, which is equal to 180 degrees. So let's solve for x. Taking the 234 to the other side of the equation, it was going to be a negative there. So you will remain with minus x on the left-hand side, which is equal to, take the 234 to the other side of the equation. The moment it jumps the equal sign, it changes the sign. So it's going to be 180 minus 234. Okay, so that's it. Minus x is equal to the difference. That's negative 54. 180. 180 minus 234 is negative 54. So this is negative x. So divide by what? Negative 1. There is just like negative 1x there. So negative, negative cancels. So x will be equal to what? A positive here. 54 degrees. All right. 54 divided by 1. All right. So that is our x. Just like that. So x is going to be 54 degrees. And with that one, we can calculate the value of y here. All right. So to calculate the value of y, we're simply going to use the concept of our co-interior angles where we form a C like that. All right. On question 4.22. As we can see, we have the x there. We have already calculated that x. So co-interior angles, y and 54 degrees is supposed to give us 180. This time we are very sure about this statement because of what? They gave us this condition that they are parallel. So we are very sure about this one this time. To say angle x, which is 54 degrees, and angle y there, when added together, we must obtain 180 degrees. So take this to the other side. Y is 180 minus 54 degrees. So y is going to give us 126 degrees. Okay, so be very careful when attempting your questions. So here, the reason is going to be angles, co-interior angles. So these are co-interior angles. The reason, this one and this one, when added together to give us 180, those are your co-interior angles from concept of what? Your parallel lines. So these are co-interior angles. Since we are told that AC is parallel to DE or DF. Okay, just like that. So this is how they can be like. So be very careful when attempting your questions. You do not assume, you use the concept the way that it is given No assumption when answering your questions, all right? On question 5, which is 5.1, we are asked to match column A with column B. All right, so it is actually column A and column C. This is C, not column B. There is 5.11, a scalene triangle. So which one shows a scalene triangle here? So that is item 2. All right, there is, all right, these are the ones, these are the only ones that we have. So a scalene, remember, all sides are not equal. They are not equal. So that was going to be this one. So 5.11 for a scalene triangle, it was going to be item 2 there. That is the best. All right, then 5.12, if we consider 5.12, an equilateral triangle, remember, all sides and angles are the same. That's the indication that we are given here on item 3. As equilateral. A right angled triangle, remember we must have what? A 90-degree. So the best answer was going to be here where there is a 90-degree on item so 5.13 for a right angled triangle. It's going to be item what? Item 4. Then 5.14 for an isosceles triangle. The best answer is going to be what? Item 1, isosceles triangle. We've got what? Two sides, only two sides that we're given that are what? That are equal. So that was on item 1. So 5.14, matching an isosceles triangle. It was going to be our item 1. All right, so that is what we had in this case. And 5.2, we have got a certain shape. That is 5.21. A, B, C, D is a what? All right, this shape that we are given, it was a tempting question because most of you were going to say this is a trapezium. No, this is not a trapezium. Remember, a trapezium, we must prove it. A trapezium, they had the same, like the similar shape. Remember, a trapezium, we said it is only one pair of parallel sides. So that makes this angle, when added to this angle, to give us 180 degrees. For those parallel sides, co-interior angle, this angle, when added to this angle, you must get 180 degrees. So if you take 110, if we say these lines, they are parallel, let's say they are parallel. If we add 110 to 85, we must get 180. But let's add 110 plus 85. It is going to give us 195 degrees, which is not 180. So it is not a trapezium. If it was a trapezium, this concept was supposed to be maintained. So A, B, C, D is not a trapezium. So what is it? It is just a normal quadrilateral. It is just a normal four-sided shape. Just a normal four-sided shape. Nothing special about it. Then calculate angle C for on 5.22. Calculate angle C giving reason. So now we know that in any quadrilateral that you have, angles, they do add up to 360, the interior angle. So to find angle C, we subtract these three angles from what? 360 degrees. All right, so angle C on question 5.22 is equal to 360 minus the three angles that are inside the quadrilateral, which is the 110. I'm going to subtract 110, the 110 again, and the 85 degrees. That's angles in a quadrilateral. All right, sum of angles. Sum of angles in a quadrilateral. So that's it. We have formed an equation. Let's solve for x. Let's solve for C, I mean. Let's solve for angle C. So angle C is going to be 360 degrees minus the sum of these three. If you're going to add, that was going to give us, right? Let us combine 110. All right, 110 plus 110 plus 85. So that's 305 degrees. All right. Then angle C from 360 degrees, 360 minus 305. 360 minus 305 was going to give us what? 55 degrees. So angle C is 55 degrees. Angles in a quadrilateral, sum of angles, sum of these interior angles is what? 360 degrees. Just like that. So you attempt the questions according to what you're given there. On question 5.3, we are given, those are the two triangles that we were given. First one, A, B, C, and D, E, F. From these two triangles, we are asked to calculate on 5.31, calculate A and B, provide reasons. Calculate A and B. All right, so that's 5.31. We can calculate angle A from this triangle DEF. All right, so to calculate angle A is going to be from triangle DEF, whatever way that you're going to name it. Angles inside a triangle add up to 180. As you can see, there are two angles that we're given. So angle A from what? From 180 degrees. We're going to subtract the 59 degrees at E and the 35 degrees at F. So that's it. Angle A is going to be 180 degrees minus these two. 59 plus 35 is 94. 180 minus 94 is going to be 86 degrees, right? So angle A is 86 degrees. Then we also need angle B, as we are given on that question, angle A and B. All right, so for angle B, right, so the reason there is just angles in a triangle, guys, all right? So for angle B, again, angles in a triangle, as you can see, these angles are in a triangle. So simply angle B was going to be 180 degrees minus the sum of the angles 86 and what? 86 and 59 degrees. You combine these two, subtract them from 180 degrees. That was going to be 145 like this from 180, which is 35 degrees. So angle B here is 35 degrees. Angles in a triangle, right? So that's angles in a triangle, sum of angles in a triangle. Okay? Just like that. So 5.31, it was just easy like that, guys. Then conclude on that. What can you conclude about the two triangles and why? What can we say about these two triangles? All right, looking into these triangles, we have an angle of 86 at A, 86. All right, there's an angle of 59 at B, 59 at E. There is an angle of 35 degrees here, 35 degrees. The three angles from the two triangles are exactly the same, equiangular. So thus, these two triangles are similar triangles. The question is conclude about the triangles. So 5.32, we can say the two triangles are similar. They are similar. So you can have it the way that you want: A, B, C, or triangle A, B, C is similar to triangle angle A to angle D, angle B to angle E, angle C to angle F. So that's triangle ABC is similar to triangle DEF. The reason is being of what? Equal angles, equiangular. It has got these two triangles, they have got equal angles. As we saw that angle A is equal to angle D of that triangle. Angle B is equal to angle E of that other triangle. And lastly, angle C is equal to angle F of the other triangle. So that's A, B, C, D, E, F. Similar. Equiangular. That is the condition. So, guys, this is how these questions will be given as. Let us just try to revise as many questions as we can as we are preparing ourselves for the exams which are ahead of time. Just try work out as many question papers. Know the basics. Know the basics as an individual. All right. So that is it, guys. Till we meet again.